Welcome to 1.5 inverse operations. Today we are going to be talking about inverse operations. An inverse operation is an operation which undoes an operation or is the opposite operation. So, for example, we are going to do adding and subtracting the same number are inverse operations. Sometimes we also think of subtracting as adding the opposite. So, if you add and you add the opposite, they are inverse operations. Multiplying and dividing are inverse operations. You can also think of dividing as multiplying by the reciprocal. So, here are some basic examples. If I have 4 plus 7 equals 11, the inverse of plus 7 would be minus 7. So if I was to build a fence and subtract 7 on both sides of the equation, I would end up with 4 plus positive 7, negative 7, which makes 0, is equal to 11 minus 7. If I was to solve this problem by building a fence, I could also do the inverse operations here. X, my variable, plus 7. Well, I want to get the variable by itself, so what's the inverse of plus 7? Minus 7. So I do that to both sides of the equation because I want to keep it balanced. And what I find is if I add 7 and subtract 7, that makes 0. So I am left with x, and again, I have 11 minus 7, which is 4. You knew that though. I can also do inverse operations with multiplying and dividing. Right here I have 5p equals 45, which is 5 times p. Build my fence. So if I have 5 times p, what's the inverse of times? Divide. Well, what is Ms. Nakamu's favorite way of showing division? Fractions. So I am going to do a fraction of divide by 5. I do it to one side of the equation, I must do it to the other side. Now the cool part is, what is 5 over 5? Secret agent number 1. Cool. So I am left with p equaling 45 over 5, which is 9. Or I can do 5p equals 45, start again with building my fence, but instead of dividing by 5, remember, I can also multiply by the reciprocal. What is the reciprocal of 5? Correct. 1/5. By definition, the reciprocal is the number you can multiply by to get to 1. So the reciprocal of 5 is 1/5. Multiply both sides by the same number. And what I see is that the 5s will simplify out. I will be left with p. 45 is the same as 45 over 1. And I could simplify down, cross simplify. 5 goes into 5 once. 5 goes into 45 9 times. And I get 9 over 1, or just 9. I could have also simplified that to 45 over 5, which then becomes 9. Great. Let's try some examples. Our goal here is to do inverse operations in order to get the variable by itself. So I have for number 1, t plus 6 equals 15. At the equal sign, I'd like you to build a fence so that you're doing the same thing to both sides of the equation. So this side will always be equivalent to this side. So my goal is to get the variable by itself. So I have t and I have plus 6. So what's the inverse of plus 6? Correct, minus 6. If you said add a negative 6, you are also correct. So I am subtracting 6 from both sides. Plus 6 and minus 6 makes 0. So I'm left with t plus 0, which is just t. And I have 15 minus 6, which is 9. Now, I really like doing a check. If t equals 9 and I plug it back into the original equation, I should get that 9 plus 6 equals 15. And is that true? Yes, it is. Awesome. Let's try number 2. Again, I'm going to start with building a fence. The fence is at the equal sign saying that this side is equivalent to this side. So I have 6 times t. So the inverse of times is divide. What's the other way I could have shown division? You're correct. Multiply by the reciprocal. What's the reciprocal of 6? 1/6. Great. So I'm dividing both sides by 6, as 6 over 6 simplifies to 1. So I have 1t. I'm just going to write t instead of putting a coefficient of 1. And then I do 48 divided by 6, which is 8. Again, I can do a check like I did in number 1. I would plug in the value of t into 8. Can I just write 6, 8? No. Where the variable is, I should put a parentheses so that I know I'm doing a times. And does that in fact equal 48? Yes, 6 times 8 does equal 48. Excellent. Number 3, t divided by 8 is greater than 7. Can I still build a fence with an inequality sign? Yes, you may. What's happening here is a little bit different. It's saying instead of these are equal, it's saying that this number is always bigger than this number. So if I do something to both sides of the equation, this side will continue to be bigger, greater than this side. So I have t divided by 8. So what's the inverse of divide by 8? You're correct, multiply by 8. So I'm going to multiply by 8 on both sides of the equation. I personally do not like how they write a times 8 because we're using variables and to use an x at the same time really gets confusing. We can discuss this more in class. Please remind me. So if I have divide by 8 and multiply by 8, that does actually simplify out to a 1, and I am left with a t on this side, and it is greater. And what is 7 times 8? Correct, 56. So this is my solution, is that in order for a number divided by 8 to be bigger than 7, the number has to be bigger than 56. I'm not going to do a check on this because if I plug this in, it would be equivalent, and the question is actually greater. Well, 3 times q plus 9, and I want to get the q by itself, so I'm going to start with the plus 9. What's the inverse of plus 9? Minus 9. If I do it to one side, I must do it to the other. So if I have 3q plus 9 minus 9, what is plus 9 and minus 9? 0. So I am actually left with 3q is equal to 27 minus 9, which is 18. Now, in my second step, I have 3 times q, so I can do the inverse operation of divide by 3, or multiply by 1/3. So if I divide by 3, do it to both sides of the equation so that it stays balanced and equivalent. The 3 over the 3 simplifies to 1. 1q can be simply written as q. And then 18 divided by 3 is 6. Want to make sure I'm right? All you need to do is plug it into the original equation. 3 times 6 plus 9, and see if it equals 27. 3 times 6 is 18. 18 plus 9 does in fact equal 27, which is what I had on the other side of the equation. Yay. Number 5, inverse operations start by building my fence. I want to get the r by itself. It's on the left side of the equation, so I want to get rid of anything that's on the left with it. Doing PEMDAS backwards, I'm going to start with adding and subtracting. I have currently a minus 6 or a negative 6, so I'm going to do the opposite or the inverse, and I'm going to add 6. If I do it to one side, I must do it to the other side of the equation. I have 3r minus 6 and plus 6, or you can think of it as a negative 6 and a positive 6, which makes 0 when added together. So I have 3r left, and 63 plus 6 is 69. And I want to continue to get my r by itself. I have two options. In this one, I divided by 3. Let's try multiplying by the reciprocal this time. What is the reciprocal of 3? Well, 3 is the same as 3 over 1, so the reciprocal is 1/3. So let's multiply this side by 1/3 also. And 69 can be the same as 69 over 1. If you are comfortable with cross-simplifying, you can cross-simplify. 3 goes into 3 once, 3 goes into 3 once, and I'm left with an r. And 3 goes into 3 once, and 3 goes into 69 23 times. And I have solved it. Whoops. Double checking that it is correct, plug it into the original problem. So 3 times r, which is 23, subtract 6, does this in fact equal 63?